Hi.
Hi.
How you doing? Are you okay? You want anything? Do you need anything? Sparkling water?
See, yeah, that would be...
No. Criminals don't get LaCroix. So, Miss Weekfeld.
It's actually
Weekfeld. It looks like you hit Joshua Garcia's car. What do you have to say about that?
It's all his fault.
Oh, really?
Yeah.
It's all his fault. My little calculations over here say otherwise. So, you know, your little bumper car buddy, Mr. Garcia, we took the friction force, the normal force, 100 newtons, 130 newtons, and we got this, 0.769. And the thing is about your truck is about 70% of the cars. We talked to the car manufacturer. So we end up getting 0.538 as your coefficient of the kinetic friction. So using this coefficient of kinetic friction, we are able to use that, plug it in, find our acceleration, right, of the car during the skid of your truck. So then we use that aforementioned, big word, don't know if you know it, but negative 5.277 meters per second squared. We plug that into our kinematic, our lovely little kinematic equation over here, and we got the velocity of the car after the collision at a whopping 10.77 meters per second. So, Miss Wheatfield, after all of this information, you want to just tell the truth? You want to stop lying?
Like I said earlier, Mrs. HPD, it was Mr. Garcia's fault.
I'll have you know I wear this hat with honor. Sicko. I'm sorry, Miss Snakefeld, but you leave me no choice. I'm gonna have to leave you with Dan the Man videos on loop.
Not Dan the Man!
Our goals are going to be
Please, no!
free force or direction, or you see
No! Please don't leave me in here! Please! It's not Dan the Man!
Mr. Garcia, is it?
Yes, that's me.
That's funny, because I actually used to have an uncle named Garcia.
Oh, really?
No, I was lying. Do you know what lying is, Mr. Garcia? Mr. Joshua Garcia, if that's even your real name. I'm sure you're very familiar with it. Lying is a crime. Perjury.
Oh,
I know you were lying. I know that you lied on January 8th, 2018 on the corner of Taft and Dallas Street in Houston, Texas. And you know what? I took the liberty to chalk up a few calculations. All right, so this right here is the coefficient of kinetic friction of the car, the tire. Right, so what we did here was take the friction force over the normal force of the tire, 100 newtons, 130 newtons, and we've got this number right here, 0.769. This is for the tire, but it also applies to the whole shebang, the whole car, your car, Mr. Garcia. Then we use the kinematic equation to find the speed of the car just after the collision, right? And we got 11.12 meters per second. Mr. Garcia, we can stop all of this. This isn't fun. It's like a project, an assignment. It's not fun. It's not fun. We can make this stop if you just
I'm good.
If you just tell me the truth.
I
That's all you
already
have to do.
have told you the truth. I'm sorry.
All right, back to the whiteboard it is. All right, let's take a second to talk about your little friend, Miss Wave Seal. So, in every collision, momentum is conserved. So we're able to use the conservation of momentum. So that means that we had the speed after the collision of the truck. We calculated that. So then we're able to use that conservation of momentum to find the speed right before the collision, which was 12.51 meters per second. So she lied. She's a big old liar. She lied about how fast she was going right before the collision.
See? She lied. She was going faster than she said she was going. So I'm right.
That's not exactly the case. So the funny thing about the conservation of momentum is that it's true. It's always true. It's true for your little friend, and it's going to be true for you too. So the thing is, we're also able to find the speed of the car before the collision using the speed of the car after the collision. So we just plugged that baby into the conservation of momentum, and we got 12.78 meters per second. This right here. Can you come here? Come a little closer. So since we have the distance between the traffic light and the scene of the crash and your acceleration, we can calculate your false velocity, the velocity you would have been moving at if you stopped at the light. If. Important word here, you didn't. You did not stop. Your velocity, as we calculated before, was much higher than 8.831 meters per second. You lied.
I would just like to say one thing.
Oh, man. Day's hard work.
In this case, though, because the object is moving in a circular path, the distance is going to be however many number of revolutions times the circumference, the distance around the circle, 2 pi r divided by t.
Yeah. Ooh, yeah.
Quiet on set. Quiet on set. Same principles that we use for your little car, and then
Welcome back, crib. Yo, the HPD is the worst.
he's not dead, the man!
I would just like to say one thing.
You ready?
That same old love.
Okay, look.
You gotta get with my friends.
Gotta get with my friends.
Gotta get nice forever.
Friendship never ends. Okay.
I don't gotta dance, I make money move. Go, go. I don't gotta dance, I make money move.
Alright. Ooh. That's it.